So hey guys, welcome back to another video. Today we'll be going to study about Amazon bug breakdown. How that bug happened and what happened inside. How people got charged about $1.5 billion, even in trillions. And what was the bug, what was the root cause, and how Amazon handled it. So let's go. So imagine logging into your AWS console to check a bill that's normally like $12 a month and seeing around $1.5 trillion. That's not a joke. That happened to real people this week, and Amazon still has not fully explained why. Let's actually break down what broke. So let's first study the timeline. What happened? So on 16 July, AWS billing estimation system started generating inaccurate data. They have this service known as billing estimator. It started generating inaccurate data. So it started accumulating inaccurate data. What happened on 17 July? So let me also show you the Twitter news that happened, right? As you can see, this e-gadget. So the cost is around, if you say it's around 2 trillion or something. And here also you can see the cost went too high. But yeah, Amazon took care of that, and how it took care of that, let's study that. So on 17 July, what happened is AWS opened an official incident investigation after users report Cost Explorer showing wildly inaccurate numbers. It validated that bug, and started investigation. What happened on 17 July at 3:03 a.m. AWS identifies the root cause, an issue with unit pricing within the estimated billing computation subsystem. So they have this estimated billing computation subsystem. This is kind of a microservice they have for billing. This was not working properly how it was expected to work. So the bug was here. They found it. They found the root cause. What happened on Friday morning? So on Friday morning, the next day, AWS admits its first fix didn't work. A rollback of a recent change did not resolve the issue. So they took a rollback, but it did not work. They rollbacked recent change, but still the issue was not gone. So expected full fix was corrected amounts by Saturday 18 July, which is today. So I think Amazon will fix it by today. So that is thing. Full fix is expected by 18 July, Saturday. Okay. Now what happened? So what happened is let's study the numbers. What happened? So the customers with normal monthly billing, let's suppose a customer has around $2 of bill, were quoted of estimation of 1.7 billion. And as you saw the tweet that shown, right, the increment, this thing, right, 1274004%, like 519,722% of increase in billing. That's kind of very funny. So the persons who were getting the bill of $2 were suddenly shocked with $1.7 billion of bill. One customer normal usage was around $0.19 per month. Like for last month, it was this amount. Now their estimation took around $2.5 billion. That's very funny, guys. I mean, 2.5 billion, even like if I am also using AWS, if I get that kind of bill, I'm not sure like what will be my reaction, but it will be shocking, of course. And now comes the third thing is some reports put figures as high as 1.5 trillion. People has also reported that they also got a billing of around $1.5 trillion. And one Reddit user claimed that he saw around $4.2 trillion of bill. So one Reddit user also reported this. Let me see, it is recording, right? So it is recording. So I think, yeah, so one console reportedly showed month over month usage grown by 74572820177.1%. Grew by these many percent. Yes. Like what to say? Now, what were the real human reactions? What were the people reactions? People reactions actually. How did people react to this? So customers, so one incident was around a UK charity that normally pays under like €1 per month was quoted about 5.8 billion, guys. Like it's roughly around that too in euros, right? 5.8 billion euros, which is roughly around $7.8 billion. Euros cost is high, right? And the account manager told the Guardian he almost had a heart attack. So the account manager of this charity, UK charity, said that he almost had an heart attack by seeing the bill. Guys, I mean, let's be honest. I mean, he could have died, guys. I mean, so one Redditor admitted they panicked and deleted their entire AWS account before realizing it was a bug. People are deleting their account because of this. So we have to take care of these kind of bugs, guys. Whenever you build a system, make sure that you separate each service. Now I will also show you that how AWS handled this very gracefully. But yeah, some people also deleted their AWS account because of panic attacks, right? Now Amazon itself leaned into the meme on X. Now this formed the kind of a meme. People were making fun of it, and people were kind of making fun of the situation, what was happening. Now Amazon itself leaned into the meme on X, calling it a slight miscalculation and joking about quadrillion-dollar estimates while confirming no customer action was needed. So Amazon said that no customer action was needed. This was the bug from their side. So no customer action was needed, right? Now, here is the headline that everyone is missing. Nobody actually owes Amazon $1 trillion, and that's not luck, it's architecture. This bug lived in exactly one place, and understanding where is the whole story. Let's try to understand. So there are two things, right? There are two things. Let me just write down system and what it does, what that system does. Of course, it's a microservice. So there is a cost explorer, estimated billing. This is a one microservice, right? Second is metering and invoicing, sorry, metering, or we can say invoicing. So this is another microservice. What happened? So what this cost explorer or estimated billing does, it forecasts your spend unit price calculations applied to usage data, right? What it does, it forecasts your spend, it predicts your spends, right? It predicts or forecasts your spends using projected unit pricing on usage data. So on usage data means the kind of data that they already have from your previous usage. So say they kind of predict it. So was it affected? Yes, this service was affected, which is the cost explorer and estimated billing. So it was affected, it was broken. This is where the actual $1 trillion numbers appeared. There was a bug here, and not in the bad guys. So it was here, not in metering and invoicing. So this service was not affected. By the way, this service is for, it records actual validated usage and generates a real invoice. So this generates a real invoice. It was not affected, right? It was completely fine. It was untouched, right? Bug was not living here. AWS runs two completely separate pipelines. One watches what you are using and generates your real invoice, which is this metering and invoicing at the end of the month. The other is forecasting, which is this cost explorer estimated billing tool that estimates what your bill might look like right now, mid-cycle, or you are not surprised later. That second, this one is a prediction engine, not a cash register. This bug broke the prediction engine. So this bug which was introduced, that broke the prediction engine, not the actual invoicing and metering. What AWS said is the root cause was an issue with unit pricing inside the estimation subsystem. So they had some unit pricing set up in their internal system. So there was a bug there. In plain English, if you see, one of the price per unit values used in the forecasting math got corrupted. Like even if there is 2, right, and if you do it 100, it becomes 200. So it is kind of a similar bug might have been introduced there. Some multiplication or like plus whatever, right? Whatever miscalculation might have happened and they might have introduced a bug there, which like multiply real usage numbers by a broken price multiplier. Normal usage doesn't just look a little high, it explodes exponentially. That's why $12 it became 1.5 trillion, because let's suppose there are multiple calculations happening on multiple stages, right? And even in one stage you have this into 2, and before that there are already happening multiple calculations, and after that also there are happening multiple calculations. So what might have happened, let's suppose I have this 1 or 2 or 1 anything, right? Now I have double this, the calculations that will be happening after that will get doubled, right? So that might be the reason that this bug got introduced and it went that high, the amount went that high. right? A single bad multiplier at the base of a calculation change compounds catastrophically by the time it reaches the display layer, right? Now, why this matters as a system design lesson? Why this matters? This matters a lot because this is actually a good example of engineering done right. Even though it looked like a disaster, right? Separating your billing system from your forecasting and billing, so you are separating these two, right? So separating these two means a bug in one can't touch the other. If the bug is here, this billing service is still unaffected, right? So that is a key takeaway why separating the systems is much needed. If AWS had one shared pipeline, if they had one shared pipeline between this for what you are predicted to owe and what you actually owe, this incident could have triggered real charges, right? If this both were in one microservice or the same pipeline, or let's suppose we are calculating the invoice after forecasting, whatever forecasting was done, and based on that we were having a billing, then that would have made real charges to the people's account, and that's not a good engineering, right? So what you are predicted to owe and what we actually owe, this incident could have triggered a real charges, real suspended accounts, real chaos. Instead it triggered panic, annoying the reversible, right? So that was the key takeaway. If you are designing any system, make sure that you separate predictions and the actual billing, the fix and the response, Let's study it. So as you can see here, AWS infrastructure, what happened, and let me just make it little bigger. So as you can see here, what happened is actual resource usage, right? AWS infrastructure. What is the infra of AWS? Cost estimation pipeline, billing pipeline, production billing, usage metering, usage unit price calculator. The bug reside here at unit price calculator. Estimated cost engine, cost explorer dashboard. Bug occurred here, right? So the bug occurred at cost explorer dashboard. Here is where the bug occurred. And in monthly invoice, this was unaffected. This was always correct, right? Now let me what was the fix? How did the Amazon responded it? So how AWS handled it? The speed was decent of the response, of course. AWS identified the root cause in roughly 90 minutes. The workaround was very good. Actually, in 19 minutes, they found the root cause. They investigated it open, genuinely fast for a global scale incident, right? And if you see, their first attempt was rolling back the recent change, which we already saw, right? It didn't work, of course. There might be some other thing they might have forget to roll back. Pause estimated billing updates. There might be cache data, right? So that might have not worked. So inflated numbers wouldn't climb any further while they worked on a real fix, right? So they paused. They paused the estimated billing updates. Billing updates were paused so they can work on the fix until then, right? The actual remedy required recomputing and backfilling correct billing data across every affected account. So what was the actual remedy? It's very important, right? Actual remedy. They might have automated it, right? Because they might have not gone through every account and do it manually, right? So yeah, the actual remedy was recomputing and backfilling correct billing data across every affected account. What do you think that data might have came from? From where it might have came? From the billing pipeline, the actual billing pipeline, right? Because, or might be from the timeline database, right? Time frame database. If you are aware about it, there is this thing called a time frame timeline database. I'm not sure, but using that, what you can do, you can have snapshots of your data depending on the time frames. This isn't the first time AWS had phantom billing scare. A similar issue hit light sale users years earlier, where customers also saw billion-dollar estimated charges that never became real invoices, right? So this is not the first time this incident has happened. It happened earlier. From that time also, people were not charged this much amount. It was just an estimation error. Now worth noting is the pattern each time is the same. Disable the broken subsystem, recompute, apologize, and move, right? It's like disable. The pattern you notice, right? Disable the broken subsystem, recompute, backfilling the data, apologize, of course, Apologize. Let me just write it here. Apologize and move. Why this is higher stakes now than in past incidents. Now cloud infrastructure is now handling far larger real spending than it used to. If you see the cloud infrastructure, people are using more and more these days, right? Like almost everyone is using cloud. They don't want to maintain their own servers and all, right? Everyone is using cloud infra. Now, so it is handling far larger real spending than it used to. Like earlier it was fine, even that incident might have happened, but right now it's not fine. They should be handling it in proper way. With AI driven compute demand pushing some individual customers actual monthly bills into hundreds of millions of dollars, which makes billing system reliability a much higher stakes problem than it was when the biggest real bills were only in thousands, right? Right now it's in like even some people might have this billing in millions, right? So they might have shocked, right? So yeah, that kind of thing is not good. Now what is the takeaway for us from this incident? You can go through Twitter, find this kind of tweets. It's already there, how this bug got introduced and what was that. You can go through Twitter, Reddit. People, there are like more discussions going through in on Reddit and Twitter. So what is the takeaway for us? If you run anything on AWS, this is a good nudge to not rely solely on AWS. AWS own estimate tools for your budget alerts, right? Just do not rely on these budget tools or estimation tools which AWS has. Independent cost monitoring tools. Use independent cost monitoring tools or alerts based on actual meter usage rather than projections would have caught this without a panic, right? We would have customers if they would have used independent cost monitoring tools. I'm not sure like people would want to use, but after this incident, like Amazon's own prediction system doesn't have much trust, is what I think. And people might look for independent tools which can work on the past data and accumulate the estimations. The whether it's emergent choosing Kubernetes pods over lightweight sandboxes or AWS keeping its forecast engine separate from its invoicing engine, the theme keeps repeating. The boring infrastructure decisions, the ones nobody put in a pitch deck, are the ones that determine whether a bug is a funny screenshot or an actual catastrophe. So make sure you divide systems. You have microservices. Systems should be independent from each other. So these kind of bugs save your company. So next time you see a screenshot of a $1 trillion cloud bill going viral, remember the story isn't the number, it's the wall between the system that predicts and the system that charges. Good architecture is why we are all laughing about this instead of suing about it. Yeah, that was about the AWS incident. Thanks for watching. See you in the next video. Please do subscribe and like. I will keep on bringing this kind of videos more and more. Thank you.